I'm going to show you a useful modification for infrared thermometers. When you're monitoring the temperature of a piece of electronic equipment, sometimes it's difficult to get to a particular device, such as the transistor in this amplifier or capacitors located by these resistors, which will be running very hot. The infrared thermometers have a fairly wide range of vision, and in fact, if you look at the scale, you'll see that as you go further out from the device, the beam pattern gets wider. This prevents you from zooming in on a particular target. You can improve the operation of the thermometer by narrowing its angle of view. In order to do that, you'll need a length of PVC pipe, 1/2 inch diameter. I prefer the gray PVC since it doesn't seem to affect the operation as much as the white PVC does. And you'll need a coupler, which is designed to be able to connect two pieces of the PVC pipe together. The process is simple. You'll glue the PVC coupler directly in front of the aperture of the infrared thermometer. This will allow you to insert the plastic pipe to narrow the field of view. Here's an infrared thermometer I've already modified. As you can see, the opening is centered directly over the sensor in the unit. So the field of view has now been narrowed somewhat by the addition of this coupler. It can be narrowed even further by using small pieces of plastic pipe of various lengths, which can then be simply inserted in the front of the unit. This will allow you to get a narrower field of view, and in an extreme case of a long pipe like this, the field of view is approximately 12 inches wide at a distance of 20 feet. Because the sensor in the unit is not fully illuminated with long tubes like this, the temperature reading will be 1 to 2 degrees Celsius lower than it would be if you were directly in front of the subject that you are monitoring. Now that we've modified the unit, let's take a look at what happens when we try and read the temperature of a transistor in the amplifier. Previously, before the unit was modified, the field of view of the thermometer was so wide that it covered the transistor, the output coil, and these drive resistors, all of which get very hot. That gave you a false reading of the transistor's temperature. Now, however, you can place the pipe directly against the transistor, and when you pull the trigger, you read just the temperature of the transistor and not the rest of the unit. You can read temperatures of similarly small items, such as this integrated circuit here. Placing the probe directly over it and pressing the button allows you to read the temperature of that unit by itself. So this is a very handy modification. I'm well pleased with the way it works. One other thing here, if you have problems with the pipe falling out of the coupler, because there are differences in dimensions of manufacture, I found that simply applying a strip of clear plastic tape around one end of the pipe will keep it from falling out very nicely, yet still allow you to remove it at will. Also, I placed a black mark on one end of the pipe so I can tell at a glance which end has got the clear plastic tape. Since it is clear, it's hard to see. Another thing that I did was I took a block of wood and drilled holes of various depths in it so that now I can insert my pipes for storage into this, and I find that this makes a very nice arrangement to hold all of the pipes so that I'm all set whenever I need to use it, and they don't get lost or mislaid. So that's the modification to the infrared thermometer. It should work with pretty much any of the ones that are on the market. I hope you find it useful, and if you like this video, please give us a thumbs up. Don't forget to subscribe to see all of our new videos when they come out, and leave us a comment if you like this video. Please let us know what you thought of it. Thanks for joining us today, and we'll see you on the next video.